June 12th, 2025. Early afternoon East Coast time. Millions of people around the world try to access Gmail, Google Docs, Google Drive, Google Maps, Spotify, Snapchat, Fitbit. Nothing loads. Not just Google services, services that depend on Google Cloud Platform, Spotify, Discord, Snapchat, even parts of Cloudflare, all down simultaneously. For over 7 hours, Google Cloud Platform experienced one of its worst outages in years. The cause? A null pointer. One of the most basic programming errors you can make. This is the story of how a fundamental coding mistake brought down services for billions of users. How even Google, with some of the best engineers in the world, can make basic errors at a massive scale. And why the internet's dependency on a handful of cloud providers keeps creating global crises. Welcome to the Breakdown Economy. I'm Tony, and today we're talking about Google Cloud Platform, the third largest cloud provider in the world, and how a null pointer crash took down massive portions of the internet. Google Cloud Platform controls about 11% of the global cloud market, behind AWS and Azure, but still massive. Spotify, Snapchat, PayPal, Twitter, parts of it, Home Depot, Target, and of course Google's own services, Gmail, Docs, Drive, Maps, YouTube. Billions of people use Google services. Millions of businesses depend on Google Cloud. And on June 12, 2025, all of that stopped working for over 7 hours. Google Cloud operates globally with regions across North America, Europe, Asia, South America, and Australia. Each region is designed to be independent, redundancy everywhere. Multiple availability zones per region, the standard cloud architecture playbook. But there's a layer beneath the regions that everything depends on. The control plane. The control plane manages services. It handles API requests. It coordinates between regions. It's the brain that tells the infrastructure what to do. When the control plane works, everything else can work. When the control plane fails, well, you're about to see what happens. At the heart of Google Cloud's control plane is something called Google Service Control, a service that provides functionality for managed services across GCP. Think of it as the traffic cop for API requests. Every time an application wants to use a Google Cloud service, Service Control validates the request, checks permissions, and manages quotas. It's critical infrastructure. If Service Control fails, APIs can't validate requests. If APIs can't validate requests, services can't function. And Service Control doesn't just manage one or two services. It manages APIs across dozens of Google Cloud products, which means when Service Control breaks, everything breaks. June 12th, 2025, a Thursday. Mid-morning on the West Coast, early afternoon on the East Coast, evening in Europe, night in Asia. Peak usage time across multiple time zones. People working, streaming, communicating, navigating. Everything dependent on Google Cloud is about to experience a very bad day. And the trigger? A policy change was made earlier that day. A configuration update to Google Service Control. The kind of change that happens routinely. Tested, reviewed, deployed. Except this one had a bug. A null pointer bug. June 12th, 2025, around noon Pacific time. Google Service Control receives a policy change. The change goes live across the system. And immediately, things start breaking. But not obviously, not all at once. This was what's called a crash loop. The policy change introduced a null pointer dereference, a programming error where code tries to access memory that doesn't exist. In simple terms, the code expected data to be in a certain location. That location was empty. The code crashed. Now, in a well-designed system, when one component crashes, it restarts and recovers. That's normal fault tolerance. But in this case, the bug was in the configuration itself. So every time Service Control restarted, it loaded the same bad configuration and crashed again, over and over. Crash, restart, crash, restart, crash, restart. This is called a crash loop, and it's a nightmare because the system can't recover on its own. 12:15 p.m. PT, Gmail starts experiencing errors. Users can't send or receive email. 12:20 p.m., Google Docs and Drive become unreachable. Documents won't load, files won't sync. 12:25 p.m., Google Maps fails to provide directions. Navigation stops working mid-route. 12:30 p.m., YouTube begins buffering indefinitely. Videos won't play. This is just Google's own services. But remember, Google Cloud Platform hosts services for thousands of other companies. Spotify, music streaming for hundreds of millions, starts failing. Snapchat, hundreds of millions of users, can't send snaps or view stories. Discord, which we covered in episode 7 for its own infrastructure problems, goes down again because Discord uses Google Cloud. Even parts of Cloudflare, which we covered in episode 9 for their outage, experience disruptions because some Cloudflare services depend on Google Cloud. And here's where the regional architecture failed to contain the problem. The service control crash affected multiple regions simultaneously: North America, Europe, Asia Pacific, South America. This wasn't a single region failing and others taking over. This was the control plane failing across multiple regions at once. Because the bug was in the configuration that got deployed globally, every region that received the update experienced the crash loop. Redundancy doesn't help when the failure is replicated to all your redundant systems. Google Cloud status page updated around 12:30 p.m. PT, about 30 minutes into the crisis. We are investigating an issue with Google Cloud Platform services. At this point, users are confused. Is it Gmail? Is it Google Cloud? Is it my internet connection? The status page wasn't specific enough to tell people what was actually broken or how widespread the problem was. For the next hour, updates continued to be vague. We're investigating. We're working on a resolution, but no timeline, no root cause identified publicly, no estimated restoration time. Behind the scenes, Google's site reliability engineering team was scrambling. Within 2 minutes of the outage beginning, SRE teams detected the anomaly and began investigating. That's actually impressive. 2-minute detection time for a complex distributed system. But detection is fast. Understanding what broke, that takes longer. They had to identify which service was failing, service control. Determine why it was failing, null pointer and policy change. Figure out which policy change caused it, recent configuration update. Develop a fix, rollback, or patch. Deploy the fix safely, without causing more problems. All while services for billions of users are down. The outage stretched through the afternoon. 1 hours p.m. PT, 3 hours in. Still down, 2 hours p.m. PT, 4 hours in. Partial recovery in some regions, 3 hours p.m. PT, 5 hours in. Still significant disruption, 5 hours p.m. PT, 7 hours in. Most services recovering. Different regions recovered at different speeds. Some areas saw services return within 40 minutes. Others took the full 7 hours. Why the variation? Because the fix had to be deployed carefully. You can't just push an update to all regions simultaneously when you're recovering from a crash loop. You deploy to one region, verify it works, deploy to another, verify, gradually restore, fast failure, slow recovery. The pattern we keep seeing with cloud infrastructure. The impact of a 7-hour Google Cloud outage was massive, and it went far beyond people couldn't check Gmail for a while. Let's start with Google Workspace, the suite businesses use for productivity. Gmail down means no email. For businesses that run on email, that's catastrophic. Google Docs and Drive down means no access to documents, spreadsheets, and presentations. Work stops. Google Meet, video conferencing, fails. Virtual meetings canceled. Remote teams can't coordinate. For companies that migrated entirely to Google Workspace, and millions have, this was a complete productivity shutdown. No email, no documents, no meetings. 7 hours of lost workday. Unlike AWS or Azure, where you might have some control over your infrastructure, with Google Workspace, you're completely dependent on Google's services working. Spotify went down hard. The music streaming service used by 600 plus million people worldwide became unavailable. No music streaming, podcasts inaccessible, playlists won't load. And this wasn't Spotify's fault. Their application code was fine. Their engineers were ready to work. But Spotify's infrastructure runs on Google Cloud. When Google Cloud's control plane crashes, Spotify can't validate API requests, can't serve content, can't function. Your platform can be perfectly engineered, and you're still at the mercy of your cloud provider. Snapchat experienced severe disruptions. Hundreds of millions of users couldn't send snaps, view stories, or access the platform fully. Discord, which had its own infrastructure problems in 2023 and early 2025, went down again. This time, not because of Discord's issues, but because Discord uses Google Cloud for parts of its infrastructure. And here's what's interesting. Discord uses both Google Cloud and other providers. They had some multi-cloud redundancy. But when core services depend on Google Cloud, even partial dependency means partial failure. Multi-cloud doesn't eliminate risk. It just reduces it. Even Cloudflare, the CDN and security provider we covered in episode 9 for their November outage, had some services disrupted. Why? Because some Cloudflare services use Google Cloud Platform for certain functions. This is what infrastructure dependency looks like in practice. Cloudflare provides infrastructure to millions of websites. But Cloudflare also depends on Google Cloud for some of its infrastructure. Layers of dependency. When one layer fails, everything above it becomes unstable. Google's post-incident response was actually pretty good, better than AWS's vague October explanation. They published a detailed analysis explaining the null pointer crash in service control, how the crash loop prevented automatic recovery, why it affected multiple regions, what they're doing to prevent similar failures. Transparent, technical, detailed. The kind of post-mortem that actually helps other engineers learn from the failure. But transparency doesn't undo 7 hours of global disruption. It just helps prevent the next 7-hour outage. Maybe. All right, let's break down what Google Cloud's June outage teaches us about infrastructure, dependencies, and basic programming errors at massive scale. Lesson 1. Basic errors can have massive consequences at scale. A null pointer dereference is programming 101 stuff. It's one of the first errors you learn to avoid when you're learning to code. And yet, Google, with some of the best software engineers in the world, deployed code with a null pointer bug to production. How does that happen? Code reviews didn't catch it. Tests didn't catch it. Deployment validation didn't catch it. Because at a massive scale, with complex distributed systems, even basic errors can slip through multiple layers of review. The bug was in a policy configuration change. Policy changes are often treated differently from code changes. Code changes get extensive testing. But configuration changes, sometimes they get a lighter review. It's just a config update. We're not changing code. Except configuration can break systems just as thoroughly as bad code, and when that configuration gets deployed globally, the impact is global. Lesson 2. Crash loops are recovery killers. Normal failure? Component crashes, restarts, and recovers. Downtime is measured in seconds. Crash loop? Component crashes, restarts with the same bad configuration, and crashes again. Downtime is measured in hours. The 7-hour duration of Google's outage wasn't because the bug was hard to understand. It was a null pointer, straightforward once identified. The length was because you can't quickly fix a crash loop. You have to identify the bad configuration, develop a fix, rollback, or patch. Deploy carefully to avoid making things worse. Verify each region before moving to the next, and you can't rush it. One mistake during recovery, and you're back to square one. Lesson 3. Multi-region doesn't mean multi-immune. Google Cloud has regions around the world. The architecture is designed so if one region fails, others keep working. But this outage hit North America, Europe, Asia Pacific, and South America simultaneously. Because the failure was in the control plane that coordinates across regions. When you deploy a bad configuration globally, you get a global failure. This is a fundamental trade-off in cloud architecture. Centralized control planes are efficient and easier to manage, but they create single points of failure. Truly distributed control planes, where each region operates completely independently, would be more resilient. But they're also more complex, harder to keep consistent, and more expensive to operate. Google chose centralization. Most cloud providers do. It makes sense most of the time, until it doesn't. Lesson 4. Dependency chains create cascading failures. Google's services went down. Expected, they run on Google Cloud, but Spotify went down, Snapchat went down, Discord went down, even parts of Cloudflare had issues. Because modern internet infrastructure is layers of dependency. Your music streaming service depends on a cloud provider. That cloud provider's security depends on another infrastructure company. That infrastructure company uses services from yet another provider. When any link in that chain breaks, everything downstream fails. And most users have no idea these dependencies exist until they fail. We've now covered 3 major cloud provider outages from 2025. June, Google Cloud, 7+ hours, Null pointer crash October, AWS, 15+ hours, DynamoDB control plane failure November, Cloudflare, 2 hours, configuration file propagation. 3 different providers, 3 different root causes. Same fundamental problem, concentrated infrastructure creating systemic risk. AWS, Azure, and Google Cloud control about 67% of cloud infrastructure globally. Add in Cloudflare for CDN services, and you've got maybe 4 or 5 companies that massive portions of the internet depend on. And 2025 showed that all of them can fail, even with world-class engineers, even with massive infrastructure investment, even with redundancy designed in. Complex systems fail in complex ways. The question isn't whether cloud providers will have outages. The question is how often and how long. After the Google Cloud outage, companies asked the same questions they asked after AWS and Cloudflare. Should we multi-cloud? Should we keep some infrastructure on-premises? Should we accept the dependency risk? And the answers are still unsatisfying. Multi-cloud. Expensive, complex, requires expertise most companies lack. On-premises backup. Need infrastructure teams that many companies no longer have. Accept the risk. Hope your provider stays online and has contingency plans for when they don't. For most companies, option 3 is the only realistic choice. Has Google Cloud improved since June? Probably. They've likely implemented better testing for configuration changes, better safeguards against null pointers in critical paths. But the next Google Cloud outage won't be a null pointer in service control. It'll be something different. A database issue, a network problem, a security update with unexpected side effects. Complex systems have infinite failure modes. So what can you actually do about cloud provider dependency? 1. Understand your specific dependencies. Which cloud provider do you use? Which of their services are you dependent on? What happens when they fail? 2. Have offline contingency plans for critical operations. If Google Workspace is down for 7 hours, can you still communicate with customers, process orders, operate your business? 3. Don't assume the cloud means always available. Cloud providers are more reliable than most companies' own infrastructure, but they're not infallible. And 4. Advocate for better infrastructure diversity and redundancy standards. The current concentration benefits cloud providers more than it benefits users. The internet shouldn't depend this heavily on 3 companies, but right now, it does. Google Cloud's June 2025 outage lasted over 7 hours. For a cloud provider serving billions of users, that's a catastrophic failure. But most of the time, Google Cloud works. Most days, Gmail loads. Most hours, Spotify streams. So most of the time, everything functions normally, until a null pointer in a configuration change crashes the control plane, and then billions of users remember that the cloud is just code running on someone else's servers. That's it for this episode of the Breakdown Economy. We've covered 10 major infrastructure failures from 2022 to 2025, from CrowdStrike to Google Cloud. Next week, we're wrapping up Season 2 with a finale that connects all these failures, what they tell us about the breakdown economy, why infrastructure keeps failing, and what needs to change. I'm Tony. Map your dependencies, plan for failures, question concentration. And remember, in the breakdown economy, even the best engineers at the biggest companies can deploy a null pointer to production. And when they do, billions of people feel the consequences.